Diverted neutral currents supplying homes. What will happen if we accidentally cut through a neutral conductor at various points leading to our homes? For this example, we'll have 3 houses connected just to show. If we were to lose the neutral conductor at this point, devices in the first home will simply turn off, while home 2 and 3 will continue to work as normal. But if we lose the neutral conductor at this point in the system, the voltage will come to the home and then become so high it will damage all your equipment, which isn't designed to take the voltage increase. There's different sizes of transformers. A 25 kVA transformer would feed approximately 10 homes, and a 300 kVA transformer could reasonably serve between 50 and 150 homes depending on local conditions and population density. Back to the houses. Now if we lose a neutral supply to house 1 on the brown phase, the house just won't have power. Power will come down the phase conductor and be unable to return, meaning the house equipment will just not function. The same will happen if this were to occur to the second house. And again, the same will happen if this were to happen to the third house. If we get a broken neutral conductor at this point leading to the houses, 1 will function properly, but house 2 and 3 will be connected in series. In this image, you can see the first house is unaffected, but the other 2 will have these voltage changes. Under normal conditions, if we measure voltage between a phase and neutral, we'll get 230 volts RMS. And if we measure voltage between phase and phase, we'll get 400 volts RMS in normal conditions. So if we go again back to the situation where we've lost the neutral, I've shown a star setup for the transformer winding. This isn't how the interior physically looks, but it's a representation. The dotted lines show the new path the current has taken to complete the circuit. It's used 2 phases. So can we calculate exactly how much voltage each property will have? Yes, we can. So we're going to calculate for the house on the black phase. But we'll need to use the voltage divider formula for each house. V out equals R1 divided by R1 plus R2 times the voltage in. The resistance of the house on the black phase, we'll say for this, is 100 ohms. After putting the figures into the equation, we'll see the voltage of the property will be 100 volts. Now let's repeat the formula for the house on the grey phase. To do this, we'll use the same formula. But the figure has changed from 100 ohms of resistance to 300 ohms of resistance. When you work out the new voltage, it's going to show a shot up to 300 volts at the property. This means electronic equipment will not work as it's not designed to operate at this. So the houses with less resistance, generally those nearer the transformer, will have lower voltage, but the houses further down the cable will have higher voltage. And bearing in mind, we said a transformer can feed up to 150 houses. Now try calculating using the voltage divider formula, the voltage that will flow through each house if the break is at the same point.